These are our salt spray machines. Salt spray is one of our most important QC measures. We put a lot of design work in to make sure that the parts are going to be as corrosion immune as possible. Here I've got a lifting eye that we went through salt spray. You can see that it's covered in salt. What's great about these machines is that in one step it helps us verify that the materials are right, that the polish is correct, that there's other things in the design like crevices that we're trying to avoid for corrosion. These machines are really important because if we do have an issue, it allows us to identify it before it leaves the factory, and we can figure out, whatever the issue was and fix it so that you, the boat owner, gets to enjoy a piece that won't rust for the lifetime of the boat. This is our UV test machine. We use this for testing mostly plastics and canvas materials. Here's an example of a couple of different canvas samples that we're UV testing. When we started getting into more shade products, this was a machine that I was really adamant about investing in because we're trying to develop a product that we know is going to be outside a lot, especially with a lot of customers in South Florida. There's a lot of harsh light. This machine simulates both day and night cycles with dew. It runs 8 hours of UV light followed by 4 hours of condensation, and that helps simulate what a natural weather cycle would be like, and that's as prescribed by the ASTM. So this is something that we can use to certify either a canvas or a plastic material, help make sure that it doesn't discolor. This is another classic piece of quality control gear. This is called a visual comparator. Sum it up, this just looks at things in a very precise way and it lets you measure visually. And it has a little readout here for how far you've moved. So for this example, I've got a screw that's on here. I can line up these crosshairs with the peak of the threads on here so we can measure the thread pitch just by going from peak to peak and measuring how far it is. So the screen here will show how far it was between the peaks. And this is a good way for us to check thread pitch visually, similar to having a thread pitch gauge, but this is a little more precise. And you can also do other sort of hard to physically measure things with this visual comparator. It's an old school piece of equipment. It looks a little bit out of place here in a modern shop, but it's a reliable piece of gear and it's easy to use. So this QC tool is not for making ice cream. This is a flatness tester. We'll use this for something that's maybe like a long sheeted part or also for a round part. So this is just a simple example of a bolt. If you can roll it along there and I don't notice that there's any sort of bend in it, that's what it's for. So you can use it to check to make sure that a rod shaped part is straight. You can also check it for a large plate shaped part to make sure that it doesn't have any wobble. It's literally just a very precisely ground flat piece of stone. Our True Design plumbing parts use NPS threads, so that's a straight thread. And to ensure that this will fit any other NPS part, we use what's called a go, no-go gauge. So a go, no-go gauge has two ends. One end that you want to go in, and the other end that you want to not go in. You want to make sure that the go end easily goes under the threads. You can thread it in by hand. So we'll check this one, get it started. Goes on easily. So we know that thread is within specification. We know that the threads are at least big enough for the go side to go in. Alternatively, it would be possible for the threads to actually be too big on the inside, and in that case you would have leaks. That would be bad. So to make sure that's not the case, we have the no-go end. So the no-go end shouldn't go in. If it does, it means the threads are oversized. So in this case, the no-go end goes in about a half turn and then it stops. I can't get it to go anymore. So these threads are within spec. We do a lot of the more basic dimensional checks with these calipers. It's a bit faster than using a visual comparator. So for example, we wanted to measure the width of this leaf of a hinge. Pretty easy to measure like that. Maybe get the barrel diameter. This is really important for things like hinges because we're trying to get the bolt pattern, like the spacing of the bolt holes correct. This is a basic test on almost any new part. We're gonna check it to make sure that it matches the drawings. Maybe it's off by 1/1000th of an inch. It's not a big deal. We'll just change the tolerance on the drawing to make it match production. But for the most part, this is where we're going to catch any sort of big design issue, is whether or not it matches our QC drawing, basic dimensions. This is another fun tool. This is a Durometer tester. This is a Shore hardness scale, which means soft things. So for example, this is one of the balls that's like a check valve in the deck drains. So this little pin here gets pressed into the ball and it measures how hard the ball is. So this one is 23.5 hardness on the Shore A scale. Just helps us verify that the foam is the density that it's supposed to be. It can also be used on rubber, so for example, gaskets. There's different testers for different hardnesses, but for soft stuff like gaskets, soft rubber, foam, this is the tester we would use for this. So what this machine is a X-ray spectrometer. And that's just a fancy way of saying it's a tool that looks into a metal to figure out what it's made out of. The main purpose of this tool is just to check that the materials that the factories are using to make the parts actually match what our engineering drawings say they should be. So for example, there's not a lot of difference between 316 and 304 stainless other than the addition of this down here. This is the big difference, and that helps prevent salt attack. It's called chloride attack. So basically, 316 is more salt resistant than 304. And we can use this machine to tell the difference. There's really no other way that you could look at it and tell the difference. For load-bearing parts, there are certain ABYC requirements that we have to meet. We have to ensure that the part is strong enough to suit whatever boat it's going to be on. Examples of parts like this are cleats, lifting eyes, anchor rods. This particular example is a lifting eye. So this is something that would maybe go in the transom of the boat. You'd use it to tie the boat down in the trailer. You'd use it to lift it up in your boat lift. The way this machine works is hydraulically operated. A pump will pull this load cell down away from the fixture that the piece is being held in. So it's a very strong test fixture. And then as this loads down, the load cell detects how much tension is in this line. These are special lifting straps that are rated to extremely high strength. So we'll fire this up, we'll pull it, we'll see what it breaks at. So we stopped the test, we had 24,296 pounds. Looks like we actually popped the pull strap. Backside with the strap and the nuts pretty much unaffected. Front side, you can see that the load is pulled down this way. Had a weld fail and the plate started to pop up, but even after 24,000 pounds, it's still intact. Pretty amazing that this little eye can support 24,000 pounds plus. This is well above the ABYC requirements for the type of boat that this would be intended for installation on. So this is a satisfactory test, really high strength.